Communication Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to our second lesson on the first law of thermodynamics and some thermodynamic quantities. Previously, we discussed internal energy and heat in relation to the concepts of thermodynamics. We learned that internal energy is the total amount of energy that is contained within a system. We also learned that heat is the energy that is transferred between a system and its surroundings. We discussed heat capacity, molar heat capacity, and specific heat. In today's lesson, we will learn about work in relation to the concepts of thermodynamics. We will learn how to calculate the amount of work that has been done based on information that has been given to us. Students, if you are ready, then we will begin. Work is similar to heat in that it is energy that is transferred between a system and its surroundings. Although there are several different types of work, today we will only discuss the pressure volume work. This type of work is done when gases are either compressed or expanded. Let us pretend that we have a gas that is confined within a cylinder, such as the one that you see here. The cylindrical container has a movable piston. F represents the force that is acting upon the piston of area A. We already know that the term pressure is defined as the force that exists per unit area. Therefore, the pressure of the gas can be determined by the formula pressure equals force over area. The term work is defined as a force that is applied over a given distance. Thus, if the piston moves a certain distance, which is represented as delta H here, then we can create the following formula for the magnitude of the work. Work is equal to force times distance. Therefore, since pressure is equal to force over area, or force is equal to pressure times area, then work is equal to force times the distance the piston moves. It is also equal to pressure times area times the change in distance that the piston moves. Students, please explain how work is similar to heat. Then define the term work as we have discussed it in this lesson.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. I wonder how you did with that activity. Work is similar to heat in that they both are a form of energy that is transferred between a system and its surroundings. The term work is defined as a force that is applied over a given distance. Were those your answers, students? If so, you are doing well. Let us continue with our lesson. The product of the cross-sectional area of the cylinder, which is represented as A here, and the height, which is represented as delta H, shows the change in volume of the gas. This is shown as delta V. By replacing area times height with delta V, which is its equivalent, we are able to see that the work associated with a gas that expands at constant pressure is described by the following equation. Work is equal to pressure times area times change in height, which is equal to pressure times the change in volume. The product of pressure and a change in volume is often referred to as pressure-volume work. When a gas expands, the change in the volume of the gas is positive and the work is negative. This negative quantity shows that the system has lost energy. The energy that was lost is transferred to the system's surroundings. When a gas is compressed by its surroundings, the change in the volume of the gas is negative and the quantity of work is positive. Students, in a moment, you will see several sentences appear on the screen, one at a time. Please read each sentence carefully and determine whether it is true or false. You may begin now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Were you able to determine whether each sentence was true or false? Let us go through them together. Sentence A is false. Work is equal to force times distance, not area. Sentence B is true. When a gas is compressed by its surroundings, the change in the volume of the gas is negative and the quantity of work is positive. Sentence C is false. Pressure is defined as the force that exists per unit area, not volume. Sentence D is also false. When a gas expands, the change in the volume of the gas is positive and the work is negative. Finally, sentence E is true. The product of pressure and a change in volume is often referred to as pressure-volume work. If you answered each sentence correctly, congratulations. You must have been paying attention. In today's lesson, we discussed work in relation to the concepts of thermodynamics. We learned that, like heat, work is a form of energy that transfers between a system and its surroundings. We learned several formulas that will allow us to calculate the amount of work done based on information that is provided. During this lesson, we specifically discussed pressure-volume work. We learned that when a gas expands, the change in its volume is positive and the work is negative. When a gas compresses, the change in its volume is negative and the work is positive. This brings us to the end of our lesson for today. In our next lesson, we will learn about thermochemistry and standard states. Until next time, thank you, teacher. Thank you, students.